This is for Tate and for Jack and for Daniel and for Josie, and is that it?
Yeah.
Okay. All right, this is R7. We're going to go through about half the notes today. Tomorrow we have a 1 o'clock dismissal, and so we have shortened periods tomorrow, so I'm hoping to get through the rest of the notes tomorrow. So we got to get through at least half of it today, if not a little bit more. Applications of equations. That is a code word for these are all story problems type of thing. Okay. So the first thing that they're talking about is, circle this, simple interest. Simple interest, this is the equation that you use for simple interest. I equals PRT. That is not PERT. Have you guys heard of PERT before?
Yeah.
That's not PE to the RT. That's continuous compounding interest. This is simple interest. This is just calculating interest at one shot, okay? So, do you know what these variables stand for?
Yeah.
I is interest. P is what?
Yes. Brian's good at it.
Principal, which is the initial payment, right? R is rate and T is time.
It's so pretty. Oh shoot.
Okay, if you need to write those in there, if you don't need to write them in there, don't have to, right? Principal means the starting amount that you borrow or whatever, right? What?
I did it.
Nice.
You did nice.
Don't take it apart. I want to look at it.
Wait, principal.
Okay, principal rate time. So they did an example where we had $5,000 as our principal. Our rate was 4%, which they convert to 0.04. Maybe make a note of that. Rate has to be in decimal form. Rate is in decimal form. So 4% is 0.04. And what's 1.5?
What if you actually put in the percent?
Probably
150.
seconds.
150. Time.
1.5 usually in years. Yep. Time is usually in years unless otherwise specified. So 1.5 years. That means we owe $300 extra for that year and a half that we borrowed $5,000. Okay. All right. Let's go to this one. I don't know what his name is, but he initially invested $8,000. What's that going for? That's principal. Invested for 2 years in a stock fund that earned 6.5% interest. What's 2? Time. What's 6.5%? Rate. And that is 0.065. Okay. The remaining money was put into an wait a second. Part of the money was invested in that, and part of the money was put in a certificate of deposit. So the other one is 8% or 0.8%. So the other R, I'm going to do a different color. The other R is 0.008 for 18 months, which is 1.5 for a time. Okay, 18-month CD, 8.8% interest. So we have two things going on here for calculating simple interest.
But we have $4,000 each.
Yep.
Yes.
Determine the amount invested into each account. This is confusing. Okay. All right. The total interest is made up of two separate parts. This guy plus this guy. You calculate interest by doing principal times rate times time, and principal times rate times time. Agreed?
Sure.
So this time we just have two things going into the interest, right? Instead of one equation, we have two of them. Okay? Yeah. What is I going to be? How much interest was there total together?
804.
804, right? It says 804 was the total interest with both groups together, okay? So the original rate was 6.5%, so 0.065, and a time was 2. But we don't know how much we put in there, right? We know that $8,000 was total, but we don't know how much we put in each, correct? So let's say we put like X amount over here, right? Let's just say that. The other account is going in for 18 months, so that is 1.5 years at a rate of 0.008, because that's 0.8% right here if we convert to a decimal. And how much are we putting in that spot?
Another X.
But we're not necessarily putting the same amount in each,
And
right?
then we set them to X equals 8 now.
Why?
I don't wanna do Y.
2x
I mean,
equals
I
8,000.
get that it'd be a different variable, but we can do better than Y. We can do it in something relationship to X. Let's say that I'm putting $1,000 here. How much do I put here? What do they add up to be total?
8,000 minus.
8,000 minus X. That's what I can put in that spot. You see that? You see how that works? Okay? So that's the equation that I use to relate the two, right? Okay? And now I'm gonna solve. Oh heavens, this is a big thing. 804 is over here just chilling out. Okay? Let's simplify some things. What's 0.065 times 2? 0.13, I think. Check me.
You're right.
0.13x. Awesome. All right, now let's do this part. What's 0.08 times 1.5? 0.016.
008.
No, that's wrong.
0.012.
0.012, you're right. 0.012 is what he is. Okay, now what do I do with that?
Can we take that? Do we need to?
Can I do this? Back distribute him. Okay,
8,000.
so I've got plus 8,000 times 0.012 is what?
96.
96
Yeah.
minus 0.012x, right? If I back distribute him, what? Where did I get 96? 0.012, this guy times 8,000 is 96. Yep. And then 0.012 times x is 0.012x. You see where I get those numbers from? Okay, now we have him, like he's still looking pretty ugly, but we have him less ugly than before, right? Okay, let's combine the 0.13 and 0.012. 804 equals 0.118x plus 96. Okay, are we doing good so far?
Hold on. Minus 96.
Minus the 96. Okay, 804 minus 96 is, I don't know, 708 equals 0.118x divided by 0.118.
6,000.
Is it exactly 6,000?
That's what I got.
That's exactly 6,000?
Let's see.
Yes, I love it.
118.
6,000, perfect.
That's what I
Okay, so let's talk about what that means.
That means that there's 2,000 in that guy.
6,000 is going in which one?
The first one.
We have a stock fund,
Let's talk.
and then we have a CD. Do you know what a CD is? A certificate of deposit. So 6,000 is going into which one? The stock fund. X was the one that had a 6.5%, right, for 2 years, and that was the stock fund. So 6,000 is going here, which means how much goes in the CD? 2,000. Does that make sense? Okay, so they made it a little tricky on you. They gave us the formula great up here, I equals PR to the T, and you're like, oh, that's easy. But then they're like, wait a second, now you're doing two things. You just add them together and that equals the total interest. So just a touch harder than that.
Yeah,
Did that follow a little bit, kind of? Okay,
I don't know if you're
Alright, we'll do a little bit more.
I could probably see my.
Yeah,
I
like
could
doing
see
it
myself
yourself
doing
might be a
this
little
more
difficult. What?
Than anything else.
What?
In life.
What?
I can see myself doing this more in life than anything else.
Right.
Yeah.
That's why, yeah. Applications, that's usually the way it works, and the most moaning and groaning comes out of this. But this is like what is the most real life, right? Yeah. But this is the thing that you moan and groan about the most, because we hate story problems, right? Okay, let's go to the next one. Mixtures. Oh, I like mixtures. We're adding things together. Okay, household bleach contains 6% sodium. How much household bleach should be combined with 70 liters of a weaker 1% solution to form a solution that's 2.5% sodium? Okay, so we're adding two things together. I'm going to do this. This solution plus this solution equals the total solution. Okay? Now, two things that are going into play: the concentration and the amount, right? So I'm going to take the amount times the concentration. I'm going to take the amount times the concentration, and I'm going to take the amount times the concentration. Okay? Amount times concentration plus another amount times concentration gives you total amount times concentration, right? Okay? All right, our first concentration is 6%. So I'm going to write him as 0.06. Can I do that?
Sure.
What's my second concentration?
0.01.
And what do I know about him?
70 liters.
He is 70 liters. So I'm going to take that amount times 0.01. Okay,
So it's point
To make, what do we know about the total concentration?
70 plus X, right?
The concentration we want to be 0.25. No, 0.025.
Oh, the.
Okay, concentration, okay? We don't know how much we're adding of the 6%. This is what we don't know we're adding, okay? We don't know how much we're adding, so let's just call it X. X amount of 6%.
Reese, you're right. X minus 70.
X amount of 6%.
X plus 70.
Okay, so do you see where we get this left side stuff from? We don't know how much of the 6%, so we're gonna call it X. We're taking 70% or 70 liters of the 1%, and then our total amount, okay? This is our amounts, X and 70. So what would the total amount be? Not 70X. We're adding X plus 70 or 70 plus X, right? Either way you do it, that's what you meant. That's not what you said, but that's what you meant, right? Do you see how this works? Amount, concentration, amount, concentration, amount, concentration. It's a little bit of a struggle setting these up. Okay? All right, let's multiply some stuff through. So X times 0.06.
0.6.
0.06X plus 70 times 0.01.
0.77.
0.7?
Yeah.
Is it really 0.7? Yeah, you're right. Equals, what do I do with that?
Foil.
We're gonna distribute. Yeah, we're gonna
Kind of
group,
Half foil.
multiply it through. 0.025X, kind of like foil, but it's only one piece. What's 0.025 times 70?
1.75.
1.75. Beautiful. Okay, how many pieces do we have right now?
4.
4. Okay, let's get the X's together. Minus 0.025X.
Ew.
Okay, and then can I subtract the 70 at the same time? Or subtract 0.7?
So it's
Minus 0.7.
0.35.
So I've got 0.035X equals 1.05. Am I going too fast? And then divide by 0.035. X equals 30 liters. Okay, let's see what they're asking for. How much household bleach should be combined with 70 liters of a weaker solution to form a solution that is blah blah blah? 30. Okay, how much is my total solution?
100.
100. 100 liters would be my total solution because we started with 70, right? Okay? Good? That was example 2. Oh boy.
Why did I get 7?
What? What you talking about?
Let me do that thing
Hurry up, broskies.
again. Hey.
They're so married.
No.
Chicken
Absolutely not.
Absolutely not.
Oh, no,
Carter,
I
what's
got
your
it.
issue here?
I got it.
Got it. Okay, great.
He's just not paying attention.
Okay. All right, here we go.
Yeah, thanks, Big Mike.
He's not quite as bad as Eli over there. Eli's totally not on the same planet right now. I can tell. Okay, sure.
Hey, how did Chase know his top 10?
Who?
Yeah, you were saying that Reese would be fine, that he would not be.
And I was right.
Okay.
Okay. Distance equals rate times time. Have you guys done that in science class?
Boo, we do that in
Boo. Boo.
I don't
Well, we didn't do that one. We
Distance
haven't done
equals rate times time. Now, here's the deal.
Same thing.
You guys,
Yeah.
he does like the triangle method with you guys, right? Does he do that?
I hate the triangle.
Yeah?
No.
So, no?
Oh,
You know what I'm talking about?
Switches them. Is that
Like
what
he
you
does,
mean?
I don't remember if it's like this.
Yeah, he switches them.
Rate times time equals distance, right?
Oh, yeah.
Is that how he
No.
writes it? How does he write it?
I have no idea, but that's not it.
equals R over D.
I don't think we know what you're talking about.
No, he doesn't write it like this?
I've
That's how he used to.
definitely seen
R
it.
equals
definitely
D
seen
over
that.
T. R equals D over T.
Right, so R would be equal to D over T, or
Yeah.
T is equal to D over R,
Yeah, he
right?
definitely did that. Yeah.
Or D is equal to R times T.
Yeah.
Yeah, that's
You
right.
see how that works? Like that's a triangle thing, okay?
don't
I don't know.
Never do that.
Let's not do that, okay.
I don't
So,
like it.
I'm just gonna look at this equation right here. If we're trying to solve for T,
Yeah.
right? If you know distance equals rate times time, we're trying to solve for T, you would divide R over, right? So distance divided by rate gives you time, okay? So you can like alter that equation to show you, like to solve for what you want, right? Okay, so let's go to this first one. All right, I'm gonna read the whole thing and then we're gonna find out what's going on. Alina takes a boat 6 miles downstream. What does that sound like?
Distance.
That sounds like a distance, I'm guessing. With a 1.5 mile per hour current, that sounds like
Your rate.
a rate. Kind of. Kind of. I'm going to put a star next to rate because that's not how fast I'm going. That's how fast it's pushing me as well. So I'm probably going more than 1.5 if I'm going with the current, okay? So that's kind of like your rate. Here we go. The return trip against the current takes 1 hour longer. Find the speed of the boat in still water in the absence of the current.
We don't want to do this.
I'm already lost.
Oh, okay, so it's like
Explain it, Eli.
1 hour equals 6 divided by 1.5x. Exactly.
Yeah, that.
Yeah, that.
Okay, what? Say that again.
1 hour equals 6 over 1.5x.
No.
No.
1.5 plus x, because we don't know what the speed
One,
is.
oh, say that again. 1.5.
No, he said 1 hour equals 6 over 1.5x is what he
1
said.
hour equal, don't write this down, equals 6 over 1.5x.
Yeah.
Is it
That's
plus
what he
x?
said.
But it needs to be plus x, right? Because we don't know the current, how fast we're going. But we know it's taking.
Is 6 miles one way?
It's without
Bro, I am not moving.
Wait, so
I don't know
time,
what they're
but
talking
time is, time has to have an x, right? Time?
I don't even
Yeah,
see
but
it.
Has to have an x,
you
I
go
don't
6
know how
miles
fast it
both
takes to go
6
there.
miles is both ways. Because the distance.
1 hour
So
plus
what did you
x?
do, 12?
No, downstream,
No,
6
because
miles
she was talking
downstream.
about
The return trip, okay, so
Here's
6
what I'm
miles
thinking.
there and 6 miles back.
Here's what I'm thinking. Distance equals rate times time, right?
Sure.
I don't know if this is right. Don't write this down yet. Distance equals rate times time. The distance going there is equal to the distance coming back, correct?
Yeah.
Like that's the only thing that stays the same. My rate is not going to stay the same because I'm going against the current and with the current. The time is not going to be the same, but the distance going and coming back is going to be the same, right? So I can have my rate times time going is equal to my rate times time coming back, right? Because that's what distance is. Distance equals rate times time. Distance equals rate times time.
Yeah.
Maybe,
Reese's got this.
maybe,
Makes more sense.
maybe.
Times time going.
But the problem is
We don't know either of these, right?
we don't know either of them. Kind of, not
We
really.
know that. We
R1,
know,
T1,
we know
R2,
that.
T2
The rate
We know
going.
that the time
is
is
1.5.
1.5.
What? The what?
Okay, so 1.5 T, right? We can leave it like that. And we can leave.
No, but the rate isn't 1.5. I'm going with the current. So my speed, let's say this is my speed. I'm gonna call it S. Speed plus 1.5 times the time
Well, we need to know the time
equals
so that we can find
speed
the speed.
minus 1.5 times the time. You see how that works?
Is the 1.5.
Weird.
Time doesn't have the 1.5.
That looks stupid.
You see how that works?
No.
We don't know.
Why are we
We don't
adding
know the time
1.5
is
over
only
there?
one.
Your
What?
speed, that's
No,
your
the
speed
time
going
is
with the
1
current.
hour.
Your speed on the way back is again the
1 hour longer.
It's T plus 1.
So T plus
Okay,
1,
so
plus
S.
1.
Yep,
and then
yep.
T.
Do you
So
understand?
this is
Kind
T
of.
plus 1 and this is T. But how do we solve for S and T at the same time?
You have to.
You just
Can we
do
just guess?
Guess and test? Who is my guess and tester?
I don't know.
Somebody always used to say guess and test.
Probably like Eli or something.
That was
Nah, I don't remember. Okay?
Okay, well.
I think we have to incorporate the 6 in there somewhere.
Well, 6 miles is the distance. Where's the distance going
Hey,
there?
Gabe,
What?
did you guess something?
No. He's not my guess and test. I want to say it's like Marcus.
No.
Oh, it was
Makes
definitely
sense.
more.
Definitely Marcus. Okay? Alright, do you see where we get our rate though from? The speed plus 1.5, that's with the current. Speed minus 1.5, that's against the current. Time is going to be one more. What?
We don't know those things.
Yeah, we don't have, we don't have a 6 in there really. Yeah.
It's divided by time.
I know, we're going to have to use the, but 6 is only one direction. What do you got?
Well,
Distance
you-
is,
Going the same.
what is it?
I'm not gonna keep
Velocity equals distance divided by time. So can we, could you just fucking 6 divided by,
I don't
I
know what
bet.
you're talking about anymore.
Yeah, we can use our our physics.
Your physics stuff?
Our
We don't-
physics stuff.
we shouldn't.
Yeah. We can find the velocity.
Really?
Why is this stumping us so bad?
Go back to your chair.
Make a big
Okay, they did it in
You
terms
guys
of,
are
they did it in terms of
I
time.
don't even know what happened.
Did you guys write that down?
Yeah.
Don't write that down.
Okay.
I'm gonna go over here.
Don't write.
All right, let's do this. The time,
So we erase all that? We're supposed to write it in the middle, but.
I wrote
I
down
read
the time coming back is 1 hour longer than the time going. Is that the same?
Yeah.
Yes.
But why does
Is
that
1
matter?
hour longer. So here we go. This guy right here. The time going plus 1 hour is equal to the time coming back. True? The time going plus 1 hour equals the time coming back.
So we plugged it in the
Okay.
plus 1 and the wrong 5.
Now, how do you find time going?
We don't.
Well, what's time? Time is distance divided by rate. Yeah? Right?
So we
Time is distance divided by
We
rate.
went 6
Okay.
divided by, are we just saying that our current?
So if time is distance divided by rate, the distance is 6, and the rate going is with the current, so that's my speed plus 1.5. Right?
Yeah, that's kind of what I
Plus
said.
1 equals the time coming back is distance divided by rate. What's the distance coming back?
I said that kind of.
What's the distance coming back? 6 divided by speed minus 1.5. Right? The rate will be whatever my speed is minus 1.5. Okay? Do you see how that works?
Yeah, for sure.
Oh.
Do we write this down?
Okay. Now write that down.
I said that.
Can you write that down? I'm gonna erase this guy and I'm gonna make him bigger. Can I do that?
No.
Now we're finding speed.
Now, do you guys understand why this one didn't work?
Because we had two
We have speed
variables.
time. We only have two variables. There we incorporate the 6, but we only have one variable there. So that's why I want to work off of that equation instead of this one. That's like a derivative of this equation, right? Kind of.
That's a big word.
It's derived from that equation.
Yeah, sure.
Yeah, sure.
Like the bottoms.
Okay. All right.
Wouldn't
Now
the
what?
one on the right
You know what
technically
you're
be
gonna
just
do.
Well, I
S
guess-
Apparently we're
S
doing that in
minus
chapter, right?
1.5,
I guess-
'cause otherwise then
I
you're
guess
in calc,
using
Really want
speed.
to, you can.
But if my cruise is set at 10 miles an hour and I'm going with the current, I'm gonna go 11.5 miles an hour. If I'm 10 miles an hour and I'm going against the current, I'm gonna be going like 8.5 miles an hour.
Oh,
Does that make sense?
Yeah.
Yeah.
I was
Okay.
looking at the wrong part.
No, you're fine. You're fine.
How much
Okay.
we have to
All right.
do the like
Now what do we do?
dummy like common denominator thing?
Ah!
Oh, wait.
Quit touching it. Quit touching it.
I don't even have the remote.
We did that one day.
All right. Yes, we need to find a common denominator. What's your denominator gonna be?
I have my phone up. I don't know if I can.
S plus or
What's your
minus
no?
T.
Can't without
S
permission.
plus 1.5, S minus 1.5.
I'm going and just
S plus 1.5, S minus 1.5. S plus 1.5,
What the?
S minus 1.5.
Guess what?
They're gonna go
It's a
away.
difference of squares.
6, 1, 6. What does the first 6 need?
An S plus minus.
Minus 1.5.
So 6S.
Okay, what's the middle one need?
Everything.
Both of them.
9, Ellie, right?
7.5.
Okay, never.
Okay, what's the
I
last
don't know
16?
Yeah, that's not right.
The last 16 is the
the
plus.
plus.
Isn't
Okay. Bottom goes away.
Oh yeah, I'm not even writing
Yeah.
the bottom.
Yeah,
That's
you're right.
too much work.
Yeah.
That's fine. You don't have to write the bottom.
I give
That's
up
fine.
on writing the bottom. Got the first two.
Oh, it's times.
Oh, I added them.
Okay, are we ready to distribute? 6 times S is 6S. 6 times 1.5 is minus 9. Plus. These are conjugates of each other, right? So the middle two pieces go away. So what's S times S?
S squared.
S squared. What's 1.5 times 1.5? 2.25. Is it minus or
Are
plus?
you sure this is gonna work?
I don't. It's plus.
No,
It's
it's not.
actually minus.
It's actually minus. Minus 2.25. Okay, the middle two pieces go away,
6
right? Because these conjugates equals 6S plus 9.
So the 9's cancel.
So we
Oh,
have to do
baby,
the-
look at this. Ready?
And the 6.
quadratic
The 9s don't cancel. Nope, just wait.
Yes.
Cause you have to minus 9.
You have to,
If we're moving.
let's add, okay,
Where's my equal?
add the 9, no, just wait, this is gonna be beautiful,
No.
Let's add the 9 over.
Are you sure? Come with your
Do you want, whatever. Okay, can I subtract the 6s? This is why it's gonna be beautiful, guys. Minus 6s. Minus 6s. We have no s's anymore.
Stop, hold on.
Yes, we do. We have 6s squared.
We have s squared,
Oh.
but that means he's not he's not a
You still have,
trinomial anymore.
Yeah, you still have.
you still have your 9s.
No, we have to
Yeah,
do
that's fine. Look at
i's.
this. No. Okay, now we're to this part. Now what?
Alright, you're adding.
20.25, right?
Add 2.25 plus 2.25. S squared equals 20.25.
4.5.
Take the square root. Is it plus and minus?
Yes,
Technically,
No,
but
it's
not,
only
because
positive.
speed is
positive.
positive. 4 point what?
4.5.
4.5. Look at that. He's not, because those 6 s's canceled out, we went from being a trinomial down to just x squared and a number. We can just take the square root. So our speed is 4.5.
Wait.
MPH. Minus speed is
MPH.
Still,
Well,
it's
you don't
still
need-
water.
We just woke up and decided.
Still water. Both though. I mean, we're not going very fast.
Yes, I do, because it's miles and miles
Are you
per hour.
It's like a serial killer.
Yeah, what if
Where
we
am I
got a
at?
training?
Okay, what?
Oh,
We have 1 minute left.
We're 1 minute left. Okay,
My
that's it.
equation I got.
That's it for the
How
day.
far can we get?
I'm not even.
It's probably-
It's called applications involving uniform motion. Let's go to,
There's no way we're getting through the rest of this tomorrow. If we couldn't even get it through today, can we?
you can get through 20,
you know how to do it.
which is 8, 10, 14. There you go.
I mean, there's no way we
You
get
can get through half of them. There's only 6 problems.
No,
Okay.
what do you mean?
I'm gonna guess that the ones that I gave you are gonna be very, 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 very similar to the ones on your notes. So just model them after
We have
those.
work day tomorrow?
No, because I'm gonna get through the notes on tomorrow.
There's no way.
What?
You're not gonna get through those.
What?
No, no,
We
no.
have
30
We
minutes.
aren't
We have
going
a full
nowhere.
30 minutes, though. This took 50 minutes. We
Go
got
with
through
your-
3.
We'll see.
You're not arguing.
Just
We'll
do.
see.
And we
Alright.